Welcome to the channel, guys. Protein coders. Let's build some coding muscles. Today, our topic is introduction to graphs. We'll go in every aspect what we're gonna cover in our upcoming videos. What is a graph? It's just a non-linear data structure in which we will have nodes or states, which often we call vertices. Right? And between every node and vertices, we will have an edge. That's it. That's simple. How simple graph is. Now let's see types of graphs. What we're going to study. Uh, the graphs are divided into various types based on different criterias. One of them is direction, based on direction. Other one is based on edge weight. Third one is based on cycles. Fourth one is based on connectivity. Right? Okay. So in directions, we will have undirected and directed graph. As the name suggests, it's very simple. In undirected, there will be no direction in edges between two nodes, while in directed ones, we will have a direction in the edge between two nodes. Okay. And we will study about the concept of integrity when we study it in more detail. Okay, next, based on weights, we will have unweighted graphs in which there will be no weight of the edges, and in weighted graphs we will have weight, as the name suggests. It's very simple, right? And don't worry, we will study in more detail when we solve questions. Now, based on cycles, we will have cyclic graphs. Let's see an example. It's an undirected cyclic graph. But in directed cyclic graph, it should be like from the node where we start, we should end up there. Okay, see, like in this example, and there is another example. Okay, but this one is not cyclic. You got my point? Because we can't end up on the same node, right? Next topic we're gonna study is graph representation. Okay, how we gonna represent a graph? There are several methods, several ways in which a graph can be represented. One of them is adjacency matrix. Okay, other one is adjacency list. Yeah, third one is edge list. In adjacency matrix, the vertices will denote the indices will denote the nodes, and if there is an edge between two nodes, we will mark it as 1 in the matrix. Okay, in adjacency list, we will have vector of vectors. Okay, for every node we will have the nodes to which it has an edge, like 0 has an edge to 1, 0 has an edge to 2. In edge list, we will directly have the edges or nodes in which we will have edges. Okay, third thing is graph traversal. We will have two types of traversals. One is DFS, depth first search. Other one is BFS, breadth first search. We will see it in more detail. In DFS, we will use recursion. In BFS, we will use queue. Okay. Next, we are going to study. And one more thing, in BFS, we also call it level wise. We will see how it is level wise when we study. Fourth one is cycle detection in graphs. And in cycle detection also, there are different methods for undirected graphs and directed graphs. For undirected graphs, we will use methods such as DFS with parent remembering. We will remember the parent, okay? With parent tracking, yeah, we will track the parent, and BFS, of course with parent tracking also only. And third, we will study later on using disjoint set union. In the directed graph, we can detect cycles using DFS and BFS. Also, it's actually a modified version of BFS called Kahn's algorithm using toposort. Okay. Next, we're going to study graph coloring. In graph coloring, we will study bipartite graphs, how to check a graph is bipartite or not, and what are the properties. Okay, in a cyclic graph, when it's bipartite or not, we will study that. Next, we're gonna study shortest path algorithms. In shortest path, we will study for unweighted, it's simple BFS. Unweighted or having same weights, if edges having same weight or unit weight, we will simply use BFS. For weighted, we will have separate algorithms like Dijkstra or Bellman-Ford, and one more we will have, which is Floyd-Warshall. We will see all of them. Next, we're gonna study is minimum spanning tree. Okay, in minimum spanning tree, we will study two more algorithms, Prim's algorithm and Kruskal's algorithm. Next, we will study disjoint set union. It's a very important data structure. Okay, and later on we will study some other advanced topics like bridges or articulate points and etc. etc. DSU is important. So, and we will see later on what else, if there are some topic lefts, we will see. But that's all the overview. Hope you like the video. If you don't like the video, don't subscribe, don't like, but if you liked it, then show some support. Thank you.